Welcome to this guide on Ethereum 2 and the merge. Ethereum, the world's second-largest blockchain network, underwent one of the most significant transformations in cryptocurrency history. This transition, known as the merge, fundamentally changed how Ethereum operates by switching from an energy-intensive mining system to an efficient staking mechanism called proof of stake. Throughout this presentation, we'll explore what this transition means, how it works, and why it matters for the future of blockchain technology. Ethereum 2 refers to a collection of interconnected upgrades designed to make the Ethereum blockchain more scalable, secure, and sustainable. The core change involves transitioning from the traditional proof-of-work consensus mechanism to proof of stake. This wasn't just a simple software update, but rather a complete reimagining of how the network achieves security and processes transactions. The merge event, which was completed in September 2022, marked the culmination of years of development and testing, officially transforming Ethereum into a proof-of-stake blockchain. Before the merge, Ethereum used proof-of-work, the same consensus mechanism as Bitcoin. In this system, miners compete to solve extremely complex mathematical puzzles using powerful computer hardware. The first miner to solve the puzzle gets to add the next block of transactions to the blockchain and receives a reward. While this system is secure, it requires massive amounts of electricity to power all the mining equipment running simultaneously around the world. This energy-intensive process made proof-of-work costly both financially and environmentally. The security of the network depends on the fact that attacking it would require controlling 51% of the total computational power, which is incredibly expensive and difficult to achieve. Proof of stake represents a fundamentally different approach to securing the blockchain. Instead of mining with powerful computers, participants called validators lock up 32 Ether as a security deposit, a process known as staking. These validators are then randomly selected to propose and validate new blocks of transactions. The brilliant part of this system is that it reduces energy consumption by approximately 99.95% compared to proof-of-work, because there's no need for energy-hungry mining hardware. The network remains secure through economic incentives. If a validator tries to cheat or behaves maliciously, they lose their staked Ether through a penalty mechanism called slashing. This economic stake ensures validators act honestly to protect their investment. Let's compare the key differences between these two consensus mechanisms. Proof-of-work requires specialized mining hardware that consumes enormous amounts of electricity. Miners compete through computational power, and transaction finality takes longer because multiple block confirmations are needed for security. In contrast, proof of stake requires validators to stake 32 Ether, but no expensive hardware is necessary. Energy consumption drops by 99.95% since there's no mining. Validators are selected randomly rather than through competition, and transaction finality is achieved faster because the consensus mechanism is more efficient. This comparison highlights why Ethereum made the transition to become more environmentally sustainable, more accessible to participants, and more efficient overall. The merge was a complex technical achievement that combined two separate blockchain systems. The original Ethereum execution layer, which handles all transactions and smart contracts, was merged with the new Beacon chain consensus layer, which coordinates validators and manages proof of stake. The Beacon chain was launched in December 2020 and ran in parallel to the main Ethereum network for nearly 2 years, allowing developers to test and refine the proof of stake system. When the merge finally occurred in September 2022, mining stopped instantly and completely. All network consensus responsibilities immediately transferred to the staked validators on the Beacon chain. This transition happened seamlessly without any downtime or disruption to users, making it one of the most successful blockchain upgrades in history. The merge brought numerous benefits to Ethereum and the broader blockchain ecosystem. From an environmental perspective, the massive reduction in energy consumption represents a significant step towards sustainability, eliminating approximately 11 million tons of carbon dioxide emissions annually. Economically, the transition lowered barriers to participation because validators don't need expensive mining equipment, just 32 Ether to stake. The security model also improved because economic penalties make attacks more costly than any potential gains a malicious actor could achieve. Perhaps most importantly, the merge laid the foundation for future scalability improvements. The network can now pursue additional upgrades like sharding, which will dramatically increase transaction throughput and reduce costs, making Ethereum more practical for everyday use. Let's recap the most important points about Ethereum's transition. First, the merge successfully transitioned Ethereum from energy-intensive mining to efficient staking, fundamentally changing how the network operates. Second, energy consumption decreased by 99.95%, making Ethereum one of the most environmentally friendly major blockchains. Third, validators now secure the network by staking 32 Ether instead of running expensive mining hardware, making participation more accessible. Finally, the merge established the foundation for future improvements like sharding, which will enable Ethereum to handle significantly more transactions at lower costs. This transformation represents a major milestone not just for Ethereum, but for the entire blockchain industry, proving that major networks can successfully transition to more sustainable and efficient systems.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.